CSRF is dead. It's finished. It's no more. You don't have to worry about it. You don't have to think about it. You don't have to develop for it, right? Well, maybe. Let's have a look. CSRF stands for cross-site request forgery, and it's the name of an attack given where you forge a request as if you're the user through their browser in order to perform some form of action. So a good way to explain it is through this simple request here. So when you've got say a post request updating the password on a user account, so mysite.com/account, you send the post request through with the new password and the server would accept it, see the password, update the database, and everyone will be happy. But if there is no CSRF protection on this request, then you can do this instead as a hacker. So first of all, and this is the important bit, you need to trick the user, get the user to somehow visit a site that you can control, a site you can run JavaScript on. Because if you can get JavaScript running in the user's browser, then you can make the user's browser do what you want. So if you've got JavaScript running in the user's browser on another site.com, it can make a post request to mysite.com/account and give it a new password. And if the site doesn't have CSRF protection, the server is going to accept that new password and change the user's password because the browser has helpfully added the cookies. So when the post request goes through to mysite.com, the browser says, oh, I know this site, I have cookies, here you go. It authenticates, lets you in, changes the password. Now the hacker has updated your password and they can log in directly to your site. And you may not even notice, the victim may not even notice this for days, months, weeks, or even years because of the long life of cookies or the infrequency at which they use the site. So that is a CSRF attack in a nutshell. And how do we defend against it? So the standard method of defending against it, and the method that you would be most familiar with working with Laravel, would be a CSRF token. And the way that works is the server generates the token, and then it attaches it to the response to the client, to the browser, in the form somewhere. And then when the form is submitted, the browser has to include this token that was generated and send it back to the server. Then the server receives the token and it validates it against the token that it generated. And it makes sure that it matches or that it's valid via some way. And as long as the token matches, it knows the request is valid, that it has come from the server to the browser, back to the server, and then it is the right request, and it can update the password. And this works because of a security feature in the browser that prevents other JavaScript on other sites from reading the content of requests on different sites. And so you cannot make a post request from another site.com to mysite.com and read the contents of the response. The request will get through and you can send the password through in the request, but the browser won't let the JavaScript read the response that comes back. And that protects you, and it protects the token because the token cannot be retrieved. If you can't use CSRF tokens or you want to use a different method, you can also use origin or referrer header. These are considered protected by the browser, and the browser won't let the JavaScript modify them at all. And so you cannot set them, you cannot override them, and therefore you can trust them on the server when they come through because you know that the browser is only attaching that information as a legitimate request. So if you can predict the value of the origin or the referrer header, you can then rely on that to defend against CSRF attacks. Another option you have is client-side cryptographic or magic. And what I mean by that is you could use public-private key encryption or some proof of work or something that makes it really hard or impossible for the attacker, for the hacker, to generate and replicate on another site.com. So they cannot generate the results that is needed on the server to verify the request. And you'd use this method if you can't retrieve tokens from the site server reliably, or if you can't trust the headers, that sort of thing. So it depends on your application how it works as to whether you need to go down that route. But there is also a fourth option to look at, which is same-site cookies. So same-site cookies they're an attribute on the cookie, and they specify the behavior of the cookie in relation to cross-site requests. And so there are three options there. You've got strict, none, and lax. And the support for same-site has been around for quite a while, a number of years. The main browsers have supported it. Safari does have a problem at the moment where same-site none is treated as strict, and so it'll block the cookies, and we'll explain all the behavior of that in a second. But apart from Safari, it's supported on all the main browsers, so you're right to use it. You should be good to use it on your sites. So same-site strict works by blocking everything, and it says you cannot send cookies on cross-site or third-party requests, which means embedded content such as iframes and images. And you can use iframes for things like transparency attacks where you overlay the iframe over something else, and the user thinks they're clicking on another site.com, but they're actually clicking on the frame which is sending those clicks back to mysite.com, and it's causing the user themselves to conduct malicious activities on their account. It also blocks unsafe requests, so say put requests, post requests, delete requests, because they modify things and they have actions. That's why they're considered unsafe, is because they perform an action, they perform some behavior. But strict will also block safe requests, so get requests, head requests. It just blocks everything, cookies across all third-party requests or cross-site requests, which makes it the most secure option and a great option if you want to lock things down. But from a usability point of view, it has a big problem. So consider your site where your users want to be logged in. Every time they visit it, they want to remain logged in. But if they're over at facebook.com and they click a link that goes to your site, when they first get to your site, they won't have any cookies because the browser will say, this is a cross-site request. We cannot send it. Even though it's a simple GET request and you clicked on a link, it's still considered a cross-site request and it will block the cookies being sent on that request. And so when the user gets to your site, they're not logged in. And as far as they're concerned, they need to re-log in again. So maybe they'll go find their login button and they'll click that. But that subsequent request is considered a same site request and the cookies will be added by the browser. And suddenly the user will be logged in. And so they will be really confused as to what's going on, where they get to the site, they're not logged in, they try to log in and suddenly they are logged in. It's just going to be confusing. So strict is the most secure option, but it does have the problem because it is the most secure option. It will block all CSRF attacks, however. Because CSRF requires third-party requests, so cross-site requests, and cookies on those requests in order to work. Strict will block everything in every CSRF attack that you attempt when it is set on a cookie, which is great, as I said, from a security point of view. Now, same-site none is the opposite end of the spectrum. So in same-site none, it says, please send my cookies on every request. So embedded content, unsafe requests, safe requests, it always sends the cookies, which is great if you need to, say, embed a form on other sites, or if you've got a multi-tenancy system where everyone has custom domains and they need to send requests, say, to your authentication domain. Same-site none will let those through. But the thing about same-site none is because it does allow cookies on all requests, the browsers have decided to require secure set as well. And the secure flag on a cookie says the cookie can only be sent on a secure request, so HTTPS. And so same-site none works only on HTTPS connections when the connection is encrypted. None, as you would expect, blocks no CSRF attacks. Because it attaches the cookie on every request, there is no CSRF protection in there at all. You need to have your own CSRF protection in order to protect these requests. If you try and use same-site none without secure, or if you try and use it on HTTP instead of HTTPS, it will not send. These cookies will never work. You cannot set a same-site cookie without secure. The browser will reject it, it won't send it, and this is something you need to watch out for if you're working with domains in local development, for example. Because if you have HTTPS in local development and you're using custom domains, the browser will request same-site none domains, same-site none cookies, I should say. And so it's something you need to account for when you're doing local dev and you need same-site none working. How are you going to manage that if you can't get HTTPS working in there? Now, the nice middle ground between strict and none is lax. So lax allows safe requests to have cookies only. So it'll block them on embedded content and block them on unsafe requests, because those two types are the ones where you generally see attacks that require cookies across sites, cross-site attacks. Now, safe requests, however, according to the nice theories, according to the ways you should be developing, safe requests, so get requests and head requests, should never perform an action. They shouldn't change state. They shouldn't have a behavior. And so they should always be safe to call as many times as you need constantly, and it shouldn't make any problems at all, shouldn't change anything. And so if an attacker can make those requests from an external site, it doesn't matter because they can't change things. And so lax says that we want to let through safe requests. And this is why it's the same default. It's a nice balance between the secure and not secure, because it blocks the routes we would normally expect attacks to come from while allowing the behaviors users would expect. So if the user's on facebook.com and then click on a link to go to your site, the cookies will be added because it's a GET request. It's a cross-site GET request, and lax will add the cookies, and the user will be happy because everything will load as expected and they will be logged in. But if there was a post request from facebook.com to your site, it would be blocking the cookie because that is, lax would block that one because it's considered an unsafe request. So CSRF attacks in lax, It's fine when all of your actions, as I've said before, are under embedded content and unsafe requests. So it'll block all CSRF attacks as long as the routes are set up properly and you're not accepting any actions on safe requests at all. So time for a bit of a story. So last year in August, I did a conference talk. It was less of a talk, more of a live hacking session. So I got up and I spent a bit of time hacking into WordPress, demonstrating a number of different vulnerabilities, how they work and how you protect against them. And one such vulnerability was a CSRF attack, and I used that to upload a PHP backdoor to the site. And it worked really well in August. Demo went perfectly. And then I was refreshing my talk. I was running through it again at the start of February because I was giving the talk at another conference. And I was in the middle of practicing, and I got to my CSRF attack and I executed the attack, checked my payload, and it wasn't there. The attack had failed. And I was a bit confused, so I checked the browser console and I saw this message. So this message come up in the console saying, a cookie associated with a cross-site resource at HackWP was set without the same site attribute. It has been blocked as Chrome now only delivers cookies with cross-site requests if they are set with same site none and secure. So for some reason, the browser, Chrome, has blocked the cookie, the authentication cookie required to execute my CSRF attack in my testing. And this was odd because I didn't have same site set on those cookies, but it reminded me that Chrome were rolling it out. So back in May last year, Chrome announced they're improving the privacy and security of the internet. And to do so, they will be using the same site cookie attribute as part of the process to make things more secure. So in October, they provided some details and insights as to what they were doing. And they said they would be defaulting all cookies that are created would default the same site lax when it's not set. And they would also require secure on same site none. And their thinking for this is they will push this out in Chrome 80 in February this year, which means that this was around the time when I was practicing my talk, but I had actually enabled it in the browser when that announcement came through. So this announcement came out in October last year, and they also said as part of this that you could manually enable them in the browser in the flags. So I had done that to test my sites to see what would break, what wouldn't break, and I'd completely forgotten. There was a couple of sites that broke at the beginning, including a few Google things, and the Australian Tax Department website broke when I was trying to play a tax bill, which was fun. I had to wait a few days to see if the payment went through or not because it was embedded in a frame, and it just went blank. So I typed in my payment details and clicked the button and the screen went blank. The frame went blank, and I wasn't sure if it had gone through or not, which part of the redirect and their flow actually had the problem. So I had to wait a few days to see if the payment went through. But most of the sites I visited worked fine with these flags, which is great, and so that's why I'd forgot about them. Now in February, Google re-announced this. I guess they reminded everyone this is what they're rolling out, saying that again we're going to make same site lax by default in this month in Chrome 80, and they announced their plans to do it as a gradual rollout. So rather than everyone getting Chrome 80 and then getting this feature, they would roll out Chrome 80 to people and they would start in very small batches enabling it across the world so that if things start breaking, if things start having problems, they can quickly roll it back or fix things, or people can identify the problem without the entire world combusting because same site lax defaulted and it breaks some vital parts of infrastructure that no one realized it breaks before. But then in April, after they had done a little bit of the rollout, and when COVID was really building up to a big thing and everything was shutting down, and people were moving to work from home, and people needed stable connections and stable applications, everything needed to be stable, the big software companies like Google and Microsoft, etc., they all announced that they would be pulling back on feature updates and focusing on security updates and bug fixes and keeping things stable. And so at this point, Chrome said in April they're rolling back their same site cookie changes. And so at this point in time, they haven't re-announced it, so no one has, at least no one on mainline Chrome, unless you've manually enabled it, has this default set for same site lax anymore. And they haven't re-announced when they're going to roll that out again, but they'll be doing it at some point. But it gives us as developers a lot more time. It gives us time to figure out what applications of ours are broken or will be broken by same site lax so we can fix our flows. Because a lot of people didn't know this was coming. They didn't really give much notice as to how long they were doing it, and it didn't get very widespread. I'm guessing quite a few of you watching this now haven't heard of same site cookies before, and yet we were supposed to be well into the rollout by now. So when they announced they would default to same-site lax, Microsoft raised their hand and said, guys, wait a second, you're going to break our flow. So as part of the OpenID Connect authentication flow, which is used by the Azure Active Directory and a Microsoft account authentication system, Lax was going to break that because of the way it works, where it sends, it sends a login request to mysite.com, which sets a CSRF token in the cookie, redirects the user to an external authentication site, and that redirects the user back via a post to mysite.com. And that final post request at the end needs to have the cookie set to validate against the authentication tokens in the post request. But because it's a post request and it's coming cross-site, same-site lax by default was breaking it. It was blocking it. And so this authentication flow stopped working. And this is a problem for Microsoft sites, not because they're Microsoft sites, but because this is on a documentation site, and it's code that other people implement on their own sites, so enterprises, corporates, even probably small sites as well, have this sort of flow. And getting them all to update their cookies is a big task. You can't simply put out a little notification with 2 months notice and say, hi everyone, change your cookie to same site none, or do this or do that. It's not going to work. And this was a big problem, and it was going to break potentially a lot of sites. So Chrome thought about this for a while and realized that this flow should only take, 2 minutes or less. So why don't we default to a thing called same-site lax plus post? And that's a special value that only works when same-site isn't set before. And what it means is let through get safe requests from the lax, but also any cookies that were created less than 2 minutes ago we will let through, which allows authentication flows like this to work, because the cookie is created for this purpose, for this flow, and it's a very fast flow within a contained time. And so you can allow it through in these requests. And so they enabled this as an option, as part of their same-site lax by default, and as a temporary feature. So they will remove it at some point, but for now it's a thing, it's how it works, and it resolves this problem until these developers have a chance to update their cookies and update their flows in order to make it work with same-site lax. So same-site domains isn't just the primary domain, but it also encompasses subdomains as well. So mysite.com is considered the same site as static.mysite.com and account.mysite.com. They're all considered the same site, which is great if you have your multi-tenancy and subdomain authentication and you need to send, say, post requests between the different subdomains. You can easily do that even with same-site strict enabled because they're all considered the same site. But what about public subdomains like github.io? Well, they're considered cross-site because there's a thing called the public suffix list. And that defines the public domains where subdomains are easily retrievable, easily accessible and are acquirable, I should say, by general users and by different people. And so if you allowed same-site requests between Laravel.github.io and Valoran.github.io, then you would have a problem. But because github.io is considered a public suffix, it blocks those, and they're considered cross-site requests, which keeps the cookies secure and keeps those requests safe. So let's have a quick look at how it works in a demo app I built. So here we've got samesitetest.net, and we're going to cookies set. Now in here, what it's doing is it's setting a couple of different cookies. So we've got strict cookie here, which is being set as strict. Lax cookie was set as lax. Secure none cookie was set with the secure flag and none and secure none, same site none, sorry. And you've got none cookie set with same site none. So we'll check over at the request, and we can see they've all been set here except for this one. So this one highlighted in yellow down here has been rejected by the browser, and the browser's rejected it because it's the same site none and secure isn't set. So that's this one on here. You can't really read it on that tagger there. And it's letting us know, it's informing us that the cookie was sent to the browser, but the browser is rejecting it. The browser is not going to save that cookie and remember it. And this is really, really helpful for debugging when you're trying to figure out why is my cookie being set, and the browser is going to tell us. They've also added this tick box over here, has blocked cookies, which will reduce down the request to only the requests that have blocked cookies coming in the response in order to further drill down to what's going on if you've got a lot of noise in the network tab. So I'll jump over to the external site, and now we're going to make a couple of requests. So we'll make a GET request first. This is a cross-site GET request. We're going from samesitetest.net through to samesitetest.com. And my demo is not working. I think I was on the wrong site running. So I'll go to com. knew I should use a different domain. Okay, so here we go again. So now we're on samesite-test.com/cookies set, sorry. We'll set the cookies, same thing. Go to the external site, which is .NET. This should work better now. So we'll go to get request, and there we go. So now we've got cookies being sent through. So this is telling us that the strict cookie, the same site strict cookie wasn't sent, lax was and secure none was. And if we check the browser, we can see the browser is listed lax and secure none, both sent through. This one, the yellow one here, it rejected it. So the browser has filtered out, hasn't sent the strict cookie because this was a cross-site request, and strict blocks every cross-site request, cookies on every cross-site request. And we got the tick box here. Again, we can hide and show the filtered out request cookies to make it easy to see what's going on with our requests. So that's a get request. Now we'll go back to the other external site and we'll run an iframe. And we'll load that up. Okay, so on an iframe, strict wasn't sent and lax wasn't sent, but secure none was. Because an iframe is considered is embedded content, and lax blocks that as well. So the only cookie that will get through on an iframe is the secure none cookie. Even if we navigate around inside here and we'll go to a get request, which normally adds the lax, it's not being added because we're still embedded. We're still within the iframe. And we go back to the external site and we run the post request now. As we can see here, the only one being sent is secure none again, because post requests again are considered insecure and lax won't have it and strict will never have it, obviously. And so that's a very basic demo on the cookies and when they're added and when they're not, and the different cross-site requests. You can go to samesite-test.com/cookies/set to set the cookies, and then follow the link to external site and see the values going through there. And I'll have a link to this at the end of the talk if you can't type that down or whatever, so you can go play with it later. Okay, so I also built an audit tool. Alongside that little tester, I built an audit tool to look at the behavior of the cookies of the different values in different browsers. And this is from Chrome with the flag set. And we can see at the top, we've got the same site requests. And as you would expect, cookies have been added to all of the same site requests except for the invalid cookies. So these are the ones that have got same site none without secure set or secure set on an HTTP request. At the bottom, you've got the cross-site requests here. Oh, go away, Chrome. Slides. Okay, so you've got the cross-site requests at the bottom, and you see most of them are blocked because it's a cross-site request. And so you see, like in the iframe columns, you've only got the yeses under the external none secure, which is the same site none secure cookie. And that's the only time you will get the cookie through an iframe. An image is exactly the same as that. Then you've got a few more in the get column, which are the laxes, and the default or the invalid values, which are defaulting to lax. And then a couple less in the post column because it's only let through on, well, we'll explain that one in a sec. So the other yeses, and what I just got confused then, was you've got the lax plus post here. So in the left column, these are the requests that were made immediately after the cookies were sent. And you can see the boxes I've highlighted there are post requests where the cookie was sent, and they're where same site wasn't set, or it was set to an invalid value, which in far as this browser was concerned meant it wasn't set. And so the cookie was sent for both the get request and the post request in these instances because the cookie was created less than 2 minutes ago. And so the post request was allowed to have cookies. But if you look in the right column, that is after the 2 minutes, you will see that they're now no. And it didn't send the cookie on the post request because it's been blocked, because the cookie is no longer less than 2 minutes old. And it's only sending through the cookies on the get requests for those in defaulting to lax. And as you can see, the secure line there is letting it through on all requests as you would expect it to do. So how does this relate to Laravel? How does Laravel implement same site? And it's pretty easy. In Laravel, in the config file, in the session config file, I should say, you've got the same site key down in there. And you can set that to whatever value you'd like to set all of your cookies to. So anytime Laravel creates a cookie, it will use this as the value for same site. By default, in version 7 and above, it's set to lax. In versions before that, it was set to null, which means it wasn't set at all. But this modifies all of the cookies that Laravel creates. If you want to create a cookie with a different value, you have to do it through the cookie builder. And if you're doing it through the cookie builder, you have to get through all the other attributes. Because it was added the most recently, it's at the end of the list. And because we're tracking Symfony, it's at the end of the list. And so you've got to get through name and value and minutes, which is fine. You want to set those anyway. But then you've got path and domain and secure and HTTP only and raw. Then you finally get the same site. And you've got to remember how many nulls there are and the true and the false, which one comes first before you get to the same site value, which is kind of frustrating. So I would recommend writing a helper function. Wrap it in a helper function where you only have to set the name and the value and the same site value. And then it'll make your life a lot easier if you have to set this on more than one request. But ultimately it's pretty easy to set because it's right there. So wrapping up, the question is, what option do I use? So use strict if the users shouldn't be automatically logged in, or you need to perform actions over GET requests if you need that extra security. So if for some reason your application requires GET requests to perform actions, you either need solid CSRF protection or you need same-side strict because it will add protection that you need there. But you only need strict if you need to do this, because strict locks down, as I said, if users shouldn't be automatically logged in. Now, use seems like none if you need to have post requests or embedded content between third-party domains. So if your site is embedded in an iframe and it needs to remember the user, then you need to use none in order to allow the cookies to be included on those embedded requests. Or if you've got, say, a multi-tenancy with custom domains and an auth domain with post requests, again, you'll need none. And for these, you'll need alternate methods of CSRF protection in order to protect your requests and prevent an attack in that regard. Now, use nothing, don't set it if you like unexpected behavior, because at some point it's going to change. So the browsers will implement same-side lax by default. Chrome will do it soon. They haven't announced when, but they'll be soon. Firefox and Edge have both said they will be implementing it as well. And I'm sure Safari will follow eventually. And so you need to learn about same-site now. You need to apply it now, work out the values that your site needs now so that things don't break and users don't get confused. And the default really is same-site lax. It works on the majority of cases. It's the same default. And it allows through safe requests. And as long as you build your application properly, then lax will work and do what you want because it works for the same requests, and it blocks CSRF on all the requests where you would expect to find CSRF attacks. So, is CSRF dead? I asked the question on Twitter and I had a pen tester come up and say, unlikely, even with same-site lax at 90% of your proof of concept still worked. So he found that even though they were using same-site lax to block post requests, cookies on post requests, he could just change it to a GET request and it would still work. It would still get through because the applications weren't built properly. They weren't designed to have all of the actions and the behavior blocked behind post. Laravel does help us with this because of the routing. You're explicit with the different methods, and the resource controllers, for example, they get you to write the code for the unsafe requests in the update and the create, and both of those are covered under the put and post, etc. And so it makes our job a lot easier as Laravel developers because the support is in there already in the framework. The framework encourages us to do it, but it is still a problem and still something you need to think about. And so Mike, back to the question, is it dead? And no, I don't think it is. I think even though we can build our applications properly and securely, and we can have same-site lax preventing CSRF attacks on our sites, it's still going to be an attack. It's still going to be able to attack websites that are out there and applications. And if you accidentally allow an action on a GET request because it's simpler and quicker and easier, then you're still vulnerable to CSRF. So I think it's still going to be a problem. In the same way that SQL injection is still a problem, because although you can use a tool like Eloquent, and it protects you against that, and it helps you to parameterize, to write proper queries that aren't vulnerable to SQL injection, it's still an attack that is used in the wild and can still be used on many sites because they aren't built properly. So unfortunately, no, I don't think CSRF is dead, but I do think as developers, we can make sure our sites are protected by using same-site cookies so that we don't have to worry about it. Thank you very much for listening. I hope you learned something. I've got notes and links to the demo app and my slides on my site there. Feel free to email me or hit me on Twitter if you have any questions, and I'll be around in the chat for a bit longer. Yeah, thank you very much.